Hello, hello. I think we are online. Hello, everyone. Hello, and welcome to which one? Which will be third uh, webinar, courtesy of the DaVinci company. Today, in this very sunny, very bright day, we're gonna talk about refactoring. Refactoring by example, because I will show you how to do a little bit of refactoring on a code that is not the worst one out there, but surely could be improved a little bit here and there. Everything I'm gonna talk about here today, it's pretty simple, pretty obvious, pretty easy, I think, to understand. But at some point in my life, I realized that everything obvious, everything easy, etc., is also pretty hard to remember for some reason. And realize that from time to time, it's nice to get a little refresher, a little reminder of how things are, how things should be, etc. And also because programming or working on front end in general is like a big pile of little things, little annoyances, etc. So, which is why from time to time we have to go back to basics. It's just too much just to remember, and it's too easy to forget even the most simple things. So, yeah, this will be an introduction for some. It will be also a little refresher for the other. So, yeah. Okay. So who am I? Hello, my name is Łukasz. I've been working for almost 8 years. In December, in January it will be 8 years on the front end as a programmer on different projects in different industries. And yeah, I actually prefer a little bit after many years. I prefer refactoring over building from scratch, because building from scratch is pretty easy. It's much easier than trying to maintain and rebuild existing, not to rebuild, but maintain and upgrade existing software, existing functionalities. Uh, and yeah, there is software out there that should be rewritten from ground up. There is software that should be retired years ago, and maintaining it and refactoring is, I would say, way too hard compared to the benefits. But a lot of the time, I would say starting from scratch is not the best option there. And also because refactoring is, how should I say it, more interesting. Let's say it's like going through a pile of random things in order to find some treasure. You don't. It's like Forrest Gump said. You never know what you're gonna find. So I find it just more interesting that way. And yeah, this is one of the reasons why we're gonna talk about refactoring today. So a little definition. This is not a technical definition. Let's not kid ourselves. There is no like industry standard definition for what refactoring is, especially considering that people tend to use some words interchangeably. If you ever been to a little discussion about frameworks or libraries, you will realize that people would call React a framework, even though it's a library. The same goes for Vue. When the Angular is the framework. I mean, everyone would know what we are talking about, but technically, when saying that React is a framework, you will be wrong. But which is why after looking for a, let's say, industry standard definition, I ended up with this one and decided that it's good enough because it contains all the necessary information, especially the second part. So basically, what is refactoring? Basically, refactoring is changing the code internally to make it better without altering the external behavior. So we are changing. We don't change the API, basically. We don't change functionalities. We don't change what the end user sees and uses. If we treat code like so-called black box, yeah, there are some controls. There are some information. There is some kind of output, there are some ways that this box can be used. So if we refactor the box, end user will not even notice. Maybe the box is a little bit faster, maybe it handles a little bit better, but in general, it's basically the same box from the perspective of the user. From the perspective of maintainer, half of the components may be different. But that's, but from the perspective of the user, and nothing changed really. The part of the small changes is also important here, because technically you can refactor basically the entire application, but at some point that application will not be the same as the previous one, even though the API is basically the same. It's I don't know if you know this idea, but it's a ship of Theseus. I don't know. I don't remember how to pronounce it. Kind of deal when ship is going on the voyage, and from time to time one part is replaced with another part is replaced, etc., etc. So at some point the ship stays basically the same, but there is no original part of it nowhere to be seen in that ship. So at which, and the question is, at which point the ship is still the original ship, and at which point it's the new ship. Yes. So the same goes here. At which point application is still the same application, and at which point when it started to become something new, which is why the small changes is really important here, because otherwise the line is a little bit blurred. I would say the easiest way to differentiate between those two is with the versioning numbers. But why is that? Because there is also the thing called rewriting. Now, this is the example of what I was talking about. With when we are refactoring, we are changing the existing code to make it better. But when we are rewriting, we are basically recreating the same application, the same functionalities, or at least most of them, or maybe some of them in some particular cases, both internally and externally. So with refactoring, we have a black box, we refactor, and from the perspective of the user, the box is the same. When we're writing, we are giving him basically the different box. There might be another button, there might be one less button, but the idea in general, the general idea stays the same. Like, this is still the black box. It still makes some sounds when clicking this on that button, but there is like 6 buttons instead of 4 at this point, or maybe 4 instead of 6. So refactoring is much bigger operation. Rewriting is much bigger operation compared to refactoring. It's like, as it is written here, going from version 1.1 to 1.2 should be refactored. Going from version 2 to version 3, that should be rewrite, because we are changing much bigger and much more important numbers, which is why I also mentioned that in the previous slide. If you need a concrete example, think about Angular. First the version of the Angular and the second one. The second one is so vastly different from the first one. It shares name and some concepts, but it's so different that the original was renamed to AngularJS at some point. And from that point on, Angular means basically version 2+. Something similar goes with Vue. There is Vue 2 and Vue 3, when it comes to a lot of concepts, is pretty same. It's pretty same, because we have components, we have props, we have events, we have center store, etc., etc. But version 3 introduced a vastly different API. Version 2 has an options API, version 3 has a composition API. And the difference between them is staggering. It's like, for React, for example, class-based components versus functional components. Both are doing basically the same things, but but the way that you can make them and how you can achieve the same results are vastly different. Which means that you can say that the version 3 of the Vue was the rewrite of the version 2 due to those very big differences. Refactor might, in this case, would mean that API stayed the same, but only, let's say, Example for that would be for the view when version 2 dropped the support for EA11, so they can use proxies to detect changes in the variables. That I would call rewrite because it altered, I would call that refactoring because it altered the internal behavior of the tool, not the external. Except for the fact that you can use view with EA11, but that's another kind of worm. So, yeah, difference between refactoring and writing the scale. Let's say that what is changed and why is changed. Refactor is much smaller. It should be. Rewriting is much bigger, and we are also building basically new thing off of the top of based on the previous one. So I said I told you all that because sometimes I see people confusing those two terms, and they are pretty similar, and those can be confused based on the amount of work on display from time to time. But yeah, the ideas behind them are much different. Okay, so this one, yes, but why refactor actually? Now, why do we even want to change the existing code? Well, there are many reasons. Here are a few examples. But the most important thing that you have to remember is that you can't really use all of them at the same time. You can't really do that because changing the code in one way might actually make it worse in other way, even. So, and also people generally don't rewrite the code when it's fine. People rewrite, refactor. People refactor, also rewrite, sorry. People don't refactor or rewrite code when it is fine. When code is fine, they just leave it at that. There's no point of changing the code when it's working and it's fine. But there are situations when the code is actually working, but for some reason it's not really fine. It's hard to read. It's very slow. It's way too verbose, etc., etc. And those are situations when we would want to refactor that code in some way. But refactoring for one reason might actually make it worse for another reason. So it's about trade-offs. It's about picking the main reason why the code should be changed, because that would also force people to pick the strategy for the refactor. In this specific case, in case of this presentation, we are gonna refactor for readability. And why is that exactly? So, first of all, we should not we should not rewrite refactor for speed when it's not really important is one thing, but when it's not really clear if the code is slow. For example, we have this here, a little method that flattens the table and then filters all of the elements that are not strings. Now, is that function slow? Is that function fast? For what sample? For how big samples of data? If it's I don't have any numbers here because I didn't do any performance testing. I didn't use the dev tools in Chrome. I didn't use console time methods, etc. So I don't know. I can only speculate. And it's not really hard, but also irresponsible to do any refactors based on guesswork or based on gut feeling. Every time someone says that the code is slow or the code is fast, you have to check it. Because this is something that you not only can do, but you also should do. Because it's easy to discuss the code when whether or not it's hard to read or not. It's because everyone has an opinion on that. But when it comes to performance, yeah, you have to use some tools for that, because it might be true that this code is slow for, let's say, a table of 100,000 elements. Yeah, and when it's slow for that big batch of data, the question should be why we even filter nested tables with 100,000 elements. Can't we do some changes maybe that direction. Yes, maybe this function is actually innocent, so changing anything here will not yield any big results because the problem is somewhere else. So yeah, so refactoring for speed requires some work beforehand, requires some testing, and then also people that are sure that this is actually the cause of the problem, that this function is actually the problem and the problem doesn't lie somewhere else. So we don't gonna do that. I mean, I could show you how to do that, but in this specific case I won't. Another thing. Oh, sorry. Yes, another thing, yeah, why we won't really want to refactor for speed, because actually fast code, yeah, can be a really hard to read. Now, what you can see on the screen is the fast inverse square root function. It's from the source code from for the Quake 3 arena. If you don't know, it's a very fast-paced first-person shooter from I would say early 2000. I don't really remember the date of the publication of it. But it is very fast game. It's a 3D game, and it has a very strong multiplayer focus. I mean, bots there are mostly addition. It's mostly competitive multiplayer game. So in this environment, you need a code for the engine that is also very fast, because you have not only the client side, but you also have server and other clients. So you have to synchronize 16 plus people. So it's which is not really that easy, especially when all the objects on the map can move in a brief space. So you need to get as much speed as possible. You have to find it whenever you can find it, and this is one of those cases. This algorithm was not created by John Carmack. I'm not really sure if he even worked on that. You can find more info about this code on the Wikipedia. There is like half an hour long explanation on how this works. It's basically some C hackery and some math, because it works with the approximation when it comes to calculating that inverse square root. But basically, people working on this function realize that there is let's say a set of results that they can get based on some input, and they prepared function to deal with that. As you can see, it's very hard to read. I mean, it's a C code, so if you ever worked with JS, you will understand this, especially when you use TypeScript. It's flow. There are types, as you can see. Long is basically also a number, but just a little bit bigger. There are floats, there is const, nothing to see here. But you have this line with 0x5f. Here is where magic happens. I mean, it happens also a line before that, but at this very point also, it also happens. I would say even bigger. So you can refactor it to be easier to read, but I would guess that it's either hard or impossible, because this code was prepared specifically to be fast, to be very, very fast, by people who knew what they are doing, who are, I think they're still alive, very skilled mathematicians that were working with a very specific problem. So that code was made for that specific purpose only. So trying to refactor this one in any way, shape, or form would be hard, if not impossible. And if you have a more readable code and you want to make it faster, there is a chance that you will do something similar. You will go lower level, for example, and you will work with the bits directly. Or maybe you will do some JS hackery. For example, you might put a plus before a variable to convert the type, which is something that some people know that they can do and some people don't know. The same goes for bitwise operations. Most of the time you won't need them, but you can do that. You can use them. So yeah, this is another reason why we are not doing refactors for speed, because we can end up with this, which is not the, I would say, the best code to read, but is the best code for that specific job. Also, think about regular expressions. Think about how validation, for example, requires them, because otherwise it's actually pretty hard to validate whether or not a data is a full number without the regular expressions, because regular expressions is like one string of commands, and that's basically it. String of commands. I mean, technically, maybe. It's one string, yeah? It's one string. You can put it in your method, and it will check whether or not phone is there or not. Doing that without regular expressions, it's a little bit harder. I would even say much harder. Much verbose. So yeah, refactoring for speed. No, it's a little bit harder. So which is another reason why we are not gonna do it here. It's not that high level of presentation here. Now, making code shorter, yeah, it's also not necessarily a good idea. This code, believe me or not, is actually pretty short. I mean, you can make const a little bit shorter. You can make the names of the variables a little bit shorter, but in general, it's one line, it's one chain of methods. It does one thing and then returns some of the values. Yes, and there is. Oh, and let's say I made a mistake. It should be type of value. It is equal number. Otherwise, I'm now returning all the values that are not numbers. Sorry for that. But the best part here is the reduce, because it's the shorter possible version of reduce that takes all the values from the table and sums them up to one value. Yes, it's really nice, but then that reduce can be a bit of a headache, because if you are familiar with the set timeout method, you know that you provide that method with callback and then comma and initial and numeric value. And we are doing the same thing here. But because that comma is right behind the callback method, there is no good indicator that the method really ended there, because comma is not really because we don't use comma to inform that the code that line of the code ended there. We are using other characters. Even in the for loop, we are not using commas. Yes. So this one little part is misleading enough. So, but the code is short. Yes, the code is very short. You can go from left to right and just read it. But the fact that it's short and can be even shorter doesn't really make it that good. I would say that it should be actually much longer, at least in some parts. And by longer, I also mean I should put it in, let's say, 4 different lines to have a better understanding what is happening. Because now I can read it from left to right, but I also have to parse it from left to right, like in one long operation. Splitting it into multiple lines would make that process much easier. So I will also not show you how to make a code shorter, because that is also a very case-to-case based situation. There is code out there that could be shorter, should maybe even shorter, but a lot of the time it doesn't really have to be, especially when builders and minifiers and additional tools will make sure that the code is actually shorter. So there is an idea that code written by humans should be readable by humans, which means that it should be verbose enough, but not more. And I would say this code is not verbose enough. It should be a little bit more, but also that should be the end. Because again, code is read by people and only interpreted by machines. So machine doesn't care how long the code is. I mean, it cares in the sense that shorter code will be parsed a little bit faster, but other than that, they don't care. So, and we should. And I would also not make the code show you how the code is update the code in a, let's say, up-to-date way of doing this. Why? The thing, okay, so we have here an example of 2 ways of replacing the content of a string. Yes, we have a method replace and replace all, the new the new tool in our toolbox. And the idea here is that we either use regex for replace to replace all the A's with B's, or we use replace all to replace all the A's with B's. Now, which one of those methods is faster? Is the second one? I'm not really sure. I would say not really. Why would it be? Because it was written in C and it doesn't use regex, but maybe it uses regex just under the hood. I don't know. I never checked the source code for that method because, yeah, you can check the source code for the JavaScript, considering that it is interpreted in the in an engine, environments, etc., etc. So replaceable might not be faster. Is it really better? In this specific case, not really. I mean, the top code, the top line does the job well enough. The second one does exactly the same, but the second one is a little bit longer, as you can see. And the only thing that changed there is replacing regex with string. But regex uses 4 letters when that string uses 3. So change there is minuscule at this point. So yeah, in this specific case, updating the method will change nothing, basically. It could change a lot when the string, for example, is longer, or maybe the regex is a little bit too slow because it's more complex. But I would argue that the change will probably not be that big. Now, replace all might be, for example, more secure, but why? Is that because it's newer? Because that's also not always the case. I would say a lot of the time it's not the case. I mean, software is not really better because the version number is higher. It's better because it's stable and there was time to fix the bugs. And think about this way. There are table methods for each map, etc. Those are still slower than the simple for each. There's just different situations when you would like to use both of them. So the only thing that is really left is the idea that replace all is more understandable because it's simple. Replace all instead of using regex that also replaces all, but requires you to know what regex even is. So updating the code, so it's, let's say, the newest one. Yeah, you can do that, but as you can see, there are situations where it's not really necessary. I mean, the conditions here are also not really that big of a deal. Like, if you understand regex and if you understand what that little g does, then you can go with the replace. And if you don't really use that much of a data, because that's another thing. Maybe for the bigger set of data, replace always better, maybe not. So if you can understand it this way, it's fine. You can leave it at that. So those are most of the reasons why I I will concentrate today on refactoring for readability. So let's do this. Okay, so we have this little piece of code. I could put it in 1 line, but I decided to put it in 5 because the creator of that code was not that bad at his job. Now, I mean, this code technically is also not bad, but it's a little bit hard to understand because for once it uses fat arrows with implicit returns, so everything is one big line, and that second part uses, as you can see, brackets, not curly brackets, but also standard normal brackets, which is like saying return this to me. Yes, this I can. If I would put it in another line, there should be return. In this specific case, that return is that little bracket on top and the bottom. This one, and this one. Is this code hard to read? I mean, kinda, but the naming is all over the place. Variables are not really the best. I mean, values of the objects are not really the best. I don't really know what this method really does. It maps. Okay, I can see that. It uses data map. So, but what does that mean exactly? So, I would say it's pretty fast, but the fact that I don't really understand what is happening here, or rather why, makes me concerned. So my primary goal here is to make it a little bit easier to read and understand. And what's the easiest thing that I can do at this very point in time? I can just split the code by lines. Yes, I can add indentations. Now, you might ask, what does it really change? Because I could read that beforehand, and now I can also read that. The result is not here, it seems, but it is actually, because now I can clearly see that one indent means one important piece of the code. One indent, I don't want to say one instruction, but let's say one piece of logic. And here we have three, yes? We have a method in a declaration, for function declaration, it takes data. Okay, that function returns data that is mapped in this specific case. So three things to take care of. And based on that, as I said, I knew that beforehand, but now, because I don't have to parse one long line, I have much easier time to understand what is happening here and what should be done in this specific case. And what should be done next, why is that? So the thing is, when you have a mechanism, and the code is basically a mechanism, just in the virtual form, in order to understand what is even happening under the hood, you have to disassemble it. And this is what we are doing here. The idea that everything can be in one line is fine and all, but it also means that that one line of code is harder to understand. It was because it was prepared not to be read, not really. If you ever checked the parsed code for the production of for this or that site, you will see that the code is one big line, maybe two, maybe three, but it's packed. It's packed because the idea there was to prepare the code to be used, not to be read. You can make it a little bit nicer using DevTools, but it will still be ugly because, again, it was not prepared to be read. It was prepared to be served to the machine. Therefore, if we really want to read the code, first of all, we have to have a source code or a code that was not, let's say, uglified or changed in a way that is just impossible to read, and then split it, then do some changes to it. Changes that will not make any functionality different, but will make the visual state different. Because also remember, we read in a very specific way. There is a reason our books have paragraphs. There is a reason that putting one big block of text with or one long sentence without pauses and such will be seen as a bad move. Yes, because it's much harder to read. So the first thing that we can do, put indentations, check for the sections of the code, how many is there and what they are doing. What we can do next, well, we can add comments also in order to understand the code and also to make the list of things that we have to figure out, because I don't know what that function is here for. I don't know the end goal, let's say end goal of this function. I don't know what data is. It can be anything, actually anything, because when you use variable names like data, you are basically saying this can be anything. If you have table of strings, I can at least understand that it will be, it will be about text. But when it's just table or object, then I will have some problems with that piece of data. Also, what is D? I mean, D is the part of data, one of the elements of data. I can understand about what is I. Now, I might be actually an index because I is like abbreviation of the word index, which is I don't want to say it's a standard practice, but you will see in a lot of libraries a lot of examples that index is a lot of the time turned into I. So I can take an educated guess that it might be actually index. And when it comes to L, okay, to uppercase. Okay, so it's a string. It has to be string. What can be L in situation like that? Maybe probably label, because also, again, I don't have any other variable in my mind that can be set to uppercase and starts with L. So maybe probably it's a label. So this function maybe probably changes the position of the element on the list because it changes its index, and also puts the label in all caps, I guess. Which is why I also added to do here, because I don't know. I want to know, and it's important to know because it's like the main thing that this function does, but I don't know and I want to understand. So comments. And it's important to add comments in situation like that because it's easy to just open the function and start reading and then jump through the code in order to find the root cause of the problem. But it's easy also to forget what we are even doing here and why. So putting comments with to-dos or other tags, putting comments in general is actually very, very helpful because we need notes for that. We are diving. We don't know how deep, we don't know how dark is there. So we need every help that we can get, and we can leave some trail behind us in the form of comments, for example. So what's next? Let's add a debugger statement. Now, debugger statement, I would argue, is not a part of a JavaScript per se. It's part. I think that's technically correct. That the debugger is a part of the browser API or maybe the environment API, because in and of itself it does nothing for the code. I mean, it does. It's when you have a method like I don't know, to uppercase, it works with the code. It comes with the code. It changes the data inside the code. Debugger does nothing. It's like a state. It's basically saying stop here. But it tells that to the browser, to the tool that runs JavaScript, not really the JavaScript itself. But that's beside the point. The point here is we need to know where this code is even used. Now, you can do that by searching through the source code with your IDE, but sometimes it's much better, much easier, much faster to just ask the code to tell us directly that the code was executed and the code stopped, and we can see well. How does it work? Okay, so here is the Chrome. As you can see, I put our little function here with the errors in the comments, and I executed it. Now, as you can see on the right, there is a local scope with all the variables, all the scripts, etc. And there is call stack. Now, call stack tells me where that function was executed. We have only 2 levels of this call stack, which is fine. But we can go much, much deeper because we can go, for example, for this. And this list can be much, much longer. But the point is, we want to know where that specific function was executed or called in order to understand why, how it works and why. And in this specific case, and then I can then go through all of this. Now, this code was minified, prepared for the production. This is code for the production actually, and formatted via the development tools, but it's still not really code that I, as a user, should see. This is code that machine should see, which is why it's really hard to parse all of this, to say what is happening here. But even then, it's still possible to actually go through that code because I still can see where that specific function could be called. So I can go there. If I click any part of this right column, I will be sent to that specific line of code. And then I can go deeper and deeper and deeper in order to find where the code was even called. Now, the problem is that with the bigger applications with a lot of additional tools and libraries, etc., it's entirely possible that most of the call stack comprised of framework code or the library code. So you would have to spend a little bit of time to find where that where your code is calling that specific function, but it's always possible. It's just a matter of time most of the time. And why we are doing that? Yeah, to find where that code was executed, why, what it does, etc. And if we go back for a second, as you can see, there are variables. I can, if here I call that method, that function with a very specific set of data, but in a lot of cases, I might not know. So putting a debugger there, going through the application in search for that function, and triggering it in some way will yield a result of a data that was passed to me from the backend, for example. So maybe production data, maybe mock data, but the data that was created specifically for that function, or vice versa. It happens. And based on that, I can work much faster because I actually understand what is passed here and what is happening to that. And from there, I can move further to check where that data is used after the mapping, etc., etc. So after this search, after going through the code, after going through the debugger, after checking when, where, how, and why. I mean, why can be a little bit problematic because how can you say why when there is no comments, for example, or documentation, or the author of the code has been out of the company for the last 3 years? You don't know. You can again take a dedication guess if you can actually see the data that is passed to the function, and you can name it. So yeah, this is another reason. We are going through the code to actually decipher why and what is happening here. So let's say that I actually understand, and I actually that yeah, I is the index and L is the label, which means that this map is just map, yeah. This function is just moving elements from the table by one position to the right, their index, presumably for the table or for the list or something like that. It might be for the situation like, I don't know, a to-do list. Yes, you add something to the list, so the list takes all the elements under that new element. It sends it to the mapper adds 1 to the I, because position of the element on the list is based on the I variable, not on the position in the array itself, because author decided to do that for some reason. And then he decided, yeah, that all the elements under the new elements should be uppercase. To make them look bigger or something. I'm not really sure. But I understand that, yeah? I mean, I don't have to be sure why a function does what it does. I need to understand how it does, what it is doing and how. So why can live for later. Maybe there is no really how. Maybe it's just how it is. I don't know. I need to talk to the designer, or I need to talk to the maybe stakeholder. But at this point, don't really care, because my idea here, my function here, is to change the code for it to be more readable. The why we can live for later, really, as long as it doesn't breaks, it's fine. So yeah, so I renamed the function. Oh, yeah, because this is another I would say is the next step. Rename things that are confusing. So method, function, move elements by one position, because this is what this function does. We have table of elements, we have single element, because we don't, those elements are from the list, but maybe they are not only to-do elements. Maybe there are other tables that uses the same function, and we are not really aware of that. We will be aware later probably, but not at this point. So this is why table of elements. And there's single element, there is index, there is label. Now you can say that, wait, beforehand there was I, element I, and L, element L. So you also change the data structure, to which I would say yes. Because the core problem here was also that the data structure was wrong. All the elements in the table had keys that were like 1 letter long, 2 letters long, etc. I can't really map. I mean, I could go with index element I plus 1, label element L to uppercase, but that would be unnecessary. I mean, if one of the problems is that the data that you are using is wrong, fix the data structure. Add additional transformation when you download data from the backend, anything. Just don't work with mangled or unstructured data with your code, because then you will leave after you a trail of functions and ugly code that exists only because someone decided to use I instead of index. Yes, go to the root cause of the problem, fix it there, fix it from there. You will end up with much less code, much nicer looking code. Don't make the same mistake that I did at least a few times in my life. Yes. Okay, so I renamed everything. It looks much better, but we can go also further, because if you use TypeScript, you can add interfaces. And now I don't have to say table of elements. I can just go element array. And I have all of the additional information available in the other places. Like, yeah, I can say that index is number and the label is string. I can deduce that. But now I have a concrete evidence that, yeah, and index is number, label is string. And I can also use it anywhere else. So if there is a chain of functions where move element by one position is like an end of it, or maybe one of the parts of it, I can reuse this interface in other places. So not only this function will be better via this little refactor, also other functions in the chain will be better thanks to this one. So if you can do that, please do. Now, what we can also do is to split this code a little bit. Now, as you can see, instead of going elements map and doing both things in one function, elements are now mapped 2 times for position and label. And again, we have map elements, which is not the best name for variable here, but I decided to, at least at this moment, use it. Now, apart from this function name, this code you can say that it has a bigger problem right now, because it was readable beforehand. I would say this is pretty much readable. I would maybe you can move elements map one line above the. I mean, you can maybe just move it up. Maybe you can get back to return being implicit. You can go back to one liner. I would say that is a good moment, because we are now assembling back our code. But other than that, that code was pretty readable. But this one, it has a little problem, because readability is a little bit subjective. For some people, code can be easy to read. For some other person, it can be an abyss, just staring at them. And in this case, I would say this code is readable, but I split one perfectly fine working function to 2. So I split the logic. So now I have to also understand that in reality, we are doing 2 things here instead of 1. And which for some people might be actually pretty messy, because now they have to go up and down to understand what is going on. And because I have 2 maps. Now, from the readability standpoint, I would say that is a little bit better, because we are doing 2 separate actions that can be merged into one, but still, it's pretty easy to understand. But the code will be a little bit slower, because instead of doing one loop through every element of the table, I'm doing one loop for the position and one for the case. So 2 loops. Now, for 10 elements, it's unacceptable. It's 20 loops instead of 10. But for 1,000 elements, we are now getting 2,000 loops instead of 1. And that can be a lot at some point. And imagine adding this additional map or additional filter. One of the reasons why some people will tell you that do not use filter map when you can use reduce is exactly this thing. Instead of going through the loop 2 times, I mean, with filter and map, you will have like one bigger loop and one smaller loop, but still 2 loops. You can go with one. So this is more of an optional step right here. Yes. because at some point you also have to understand that you can refactor. Theoretically, you can refactor infinitely, but there is a point where you should stop, and that point can be here, can be there, but it's somewhere. Yes, and for some people that point is too far. For some people, it's not enough. For others, it's perfect. So you also have to decide to where. So to sum all of this up, this is a process. Yes, I had a mechanism, I disassembled it, I checked it, I ran it, I fixed it a little bit, moved the parts here and there, replaced some parts even, add some parts, and then assemble it again. It works exactly the same. So it's a process. This process can be long, the process can be slow, but it's a process nonetheless. It's about small steps. As you can see, I added some indentations to my code. That was a step. That was one step. That was nothing. That was like a few seconds stop, but it gave me an insight onto how this function works. So small step, big gains. Sometimes also small steps, small gains, but gains nonetheless. Uh, as I said, it's a process. Yes, a process of consisting of small steps that we should lead us somewhere. Yes. It's about trade-offs, because yeah, I can make code a little bit more readable, at least in the eyes of some, but it may be slower a little bit. It might be or feel outdated, because in the previous example, I can technically use a for loop. Yes, I don't need to use map. I can use a for loop and then return the result, and that will also be fine. That might also be better, because for loop will be technically faster than the table methods. At least for also to some degree, there are situations where for loop will actually be slower. It also requires some performance tests. So don't take my words at the face value. Yes, this is not this kind of situation. But yeah, as you can see, you can make the code better in some ways, but it might also get worse in other ways. It's about picking the strategy, picking the end goal, and sticking to that. Because yeah, you can try to refactor code for every possible purpose, but you will end up with something a little bit messy. It's like writing a code for testing in tests in mind. Yes, if you don't have tests in mind, your code will be a little bit different than the code that you wrote with tests in mind. But then it might be easier to test, but it also might be harder to write, might be harder to read. It might be some problems with it that you didn't anticipate at the very beginning. So yeah, you write code. I mean, you refactor also for a specific purpose. There is always an idea behind it. And yeah, I would say that is basically it. That was refactoring by example. A very simple refactoring by very simple example. But as I said, all of this is in general very easy. All the tools that you can use here are also pretty easy. I mean, as long as you don't use some things like, I don't know, SonarLint that will tell you how to make code readable for you, means suggesting. All the tools that you have in your disposal are pretty simple. It's just a matter of using them in a way that benefits you and your code, and that's basically it. Is there any questions? Maybe there's a singular question. Who knows? Okay, I don't see any questions. So, okay then. So, thank you for coming to this little talk today, this very nice, bright, sunny day. I hope you get something out of it. Even one thing will be enough for me, because, as I said, small steps, always small steps. If you liked what I said, if you like what I'm doing on this channel, please like, comment, subscribe, bell, all of that jazz. Also, please check our other materials, our other webinars, or other streams if you are into that sort of things. Please stay tuned for the next one. It should be scheduled for the 2 weeks from now. It won't be made by me. Someone else will will be with you, but at the time. Also, please check our website. We have some options for the workshops there, for the workshops, for the mentoring, events and services, let's say, to help you, to help your team, to increase your programming skills, to help you identify problems with code, etc., etc. There might not be much offers now. There will be more in the near future. So if you want to stay stay up to date, then please subscribe to our newsletter. You will find it on our website. And I would say, yeah, that's basically it. So thank you again for coming here. I hope that this little talk will be of any use to you. And I hope that I will see you around next time. So thank you again, and till next time. Goodbye.